Hello everyone, in this video we're going to go over section 4.1, which is about graphing trigonometric equations. So we're going to go over the basic graphs of sine, cosine, tangent, and so forth. And then in the next sections we will just expand on this. Now, we kind of talked about the unit circle before, but now we'll go in more detail because we're going to need these values to do the graphs, and they will be typically the same values they will be using all the time. And when we say unit circle, we really mean like, the circle on the quadrants. And now for the graphs, we're going to need technically only 5 points. So we're going to need 0 degrees, 90 degrees, 180, 270, and 360. Okay, so that's what we're going to focus on. So remember, this is 0 degrees or 360. So we use radians. We're going to use radians now. This is pi over 2, which remember is 90 degrees. 180 degrees, which is pi. And then this one is 270 degrees, which is 3 pi over 2. Okay? So the values that you need to memorize are the following. So we're talking about sine, which is the first graph we're going to do. You need to memorize the values at these points. Okay? So this will be x, and then obviously this will be sine of x. So if x is 0, this is 0. If x is 90 degrees, this is 1. Okay? And then if this is pi, this will be 0. And the next one is 3 pi over 2. This will give you minus 1. And then finally, 2 pi goes back to 0. Okay? So these are the values you need to memorize for sine. And we have similar values for cosine and tangent. Okay? Actually, for sine and cosine, they're the same values. Then if you want to do the graph, the basic graph is going to be this. So we're going to start in 0 degrees. Then we're going to have pi over 2. And then pi. And then 3 pi over 2. And finally 2 pi. So they are supposed to be equally spaced. And then the highest this goes is 1. And the lowest it goes is minus 1. So therefore 0, 0 is here, which corresponds to this value. And then when this is pi over 2, this is 1, goes down to 0, negative 1, and 2. So as you can see, this is technically pretty straightforward. Even though it looks pretty fancy, it's pretty simple. Now, one thing we're going to be concerned about is something that is called the amplitude. Okay? So the amplitude is the highest value that you get from this line. So you can see the highest this can go is 1, and the lowest it can go is 1. So therefore the amplitude for this case is 1, which is the highest or lowest value you can go in absolute value. And then another thing we're going to focus on right now is the period. And the period is how long it takes to get to the starting point. If you keep going, this is going to look like this. It's going to have another period. So notice that the distance between here and here is 2 pi. So therefore the period will be 2 pi. In the coming sections, we're going to change the graph to have a different period, which means the graph will technically be contracted or expanded. But for now, this is what we mean by period and amplitude. Now, notice that if we would have, let's say, a different graph right here, and we have, let's say, y equals to 4 sine x, you will always go back to the original graph which is this one, you're going to have the exact same values, 0, pi over 2, pi, 3 pi over 2, 2 pi. And notice that the period is not going to change because it goes from 0 to 2 pi. But now the values are going to change. So 0 times 4 is still 0, but this will give you 4, 0, minus 4, and 0. So in this particular case, the only difference is that the graph now is going to look exactly the same. This is still going to be 2 pi. This is going to be 0, but now this will be 4, and this will be minus 4. So the amplitude, which we're going to use the letter A, the amplitude now is going to be 4, but the period is still 2 pi. So now we're going to move on to cosine, which it has the exact same base points. This is what I call the base points, but these numbers go in different order. All right, so now let's look into cosine. Now for cosine, we're going to use the same x values. X will be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay. But now the values, and these values you should memorize. This one starts in 1, then it becomes 0, then it becomes minus 1, 0, and it goes back to 1. So notice that the x values are the same values that you use for sine. So then this is 0, pi over 2. So notice same values as cosine. 3 pi over 2 and 2 pi. And we still want to go to 1 and minus 1. So therefore, now we're going to start here. Then we're going to go here, 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 and here. So that will be one period, which looks like this. And then this technically keeps going. So we'll do this and so forth. Okay? But from here to here is a period. So for sine and cosine, the amplitudes are the same. It will still be 1. And the period is 2 pi. So they are exactly the same. Okay. Now, if you have a different function where you multiply this by, I don't know, 5, so then the amplitude will be 5. So it goes up. Okay. In the coming sections, we will focus when we made the graph shorter, like the period will be smaller, or you can make the period longer. Okay? Now, remember that cosine is related to secant. So recall this. Recall the secant theta is the same thing as 1 over cosine theta. They are reciprocal of each other. So therefore, how would you use that to do the graph of cosine? Remember also that you cannot divide by 0, okay? So if you divide by 0, this will be undefined. So therefore, we're going to use this graph to graph secant. So notice that this is 0 right here. Let me even use a red. So this will be 0 here and 0 there, okay? So therefore, this is what you're going to do. You're still going to have the same values, which is still 0 here, still pi over 2, pi, 3 pi over 2, and 2 pi. Same exact values, okay? So the only difference is when this is 0, which corresponds to pi over 2, you're going to have something that's called an asymptote, which is a line you cannot cross. So you have one there and one here, okay? So then let's just do the same graph in here. So let's say this is 1, and this is negative 1. So I'm going to just rewrite the graph, but the original graph, and by that I mean this, as a dotted line. So remember, this one will look like this. So this is the graph of cosine. So how do we find the graph of secant then? So we will come here where this touches. So you will do this and this. Remember, you cannot cross this line. Same thing here, you will do this and this. So that's how you graph secant. By the way, you can do the same thing with sine. You want to graph the graph of cosecant. Remember that sine looks like this. Remember this was sine of x. So this is 0 here, and 0 here, and 0 here. So just do the asymptotes there. So here, here, and here. And then you do the same graph as a direct graph, which it looks like this. So therefore the graph for cosecant, it would look like this. Here and here. Okay? So it's actually pretty simple. Finally, let's look to the graph of tangent. So remember, cosine, sine use the same x values, but tangent uses slightly different values. So for tangent, these are the values you're going to use. Okay. So here we're going to use minus pi over 2, which is technically 270 degrees. We're going to use minus pi over 4. We're going to use 0, pi over 4, and pi over 2. And you should memorize these values. At this point, this will be 0. This is actually 1, negative 1. This is undefined, which means it doesn't exist. And at this point, it's also undefined. So now if we do the graph, you have 0. This is pi over 4. Then pi over 2, minus pi over 4, and minus pi over 2. Okay? So since the graph is undefined at the points negative pi over 2 and pi over 2, so you just do an asymptote here, here. And then let's say this is 1, so therefore this is negative 1. So at this point, this is 0, here, and here. So the graph is going to look something like this. And notice it will never cross the line pi over 2 or minus pi over 2. Also, the period for this one is not 2 pi. So the period is just pi. So it means it will repeat every pi. So we'll do this, and then it will do this again, and so forth. So the period is pi. And this one, since this is going to infinity, it has no amplitude. So the amplitude is none, or it doesn't exist. Okay? So this is how the graph of tangent looks. Now, what would be the difference if I ask you to graph, let's say, y equals to 3 tangent x? The only thing is that instead of this being 1, now this will be 3. This will be minus 3. Remember that that's not the amplitude, and these values will not change. Like I say already a couple times, in the comment sections, the period will change. But for now, the period for tangent, it will stay pi, and for cosine and sine, it will stay at 2 pi. So then for this case, the graph will look something like this. Okay? And that's it.